back. We are looking at trapezium rule for finding definite integral. So what we need to note in this place is to know the formula. What is the formula? Okay, so once you know the formula, then the next question is how do we use the formula? And it's very simple. So this is the formula for trapezium rule. The function y dx. This is the upper and this is the lower. The upper is b, the lower is what? A is approximately equal to, okay? Here, find the integral. This is the integral we have, integral of sec x, and we have the upper boundary pi over 3, and 0. Then b part, use the trapezium rule with two strips to estimate r. And then c part also, we have it, use the trapezium rule with 4 to find a second estimate for r. And then d, find the percentage error in using these two estimates for r. So without wasting time, the first part, the a part, integral of ln, okay, the a part, integral of this, it has a table, it's a direct table, and that will be ln sec x plus what? Tan x. So it's a direct table, so it's straightforward. Integral of this will give us this. Then indicate your upper and then your lower boundary. So then the next thing to do now is to begin to substitute sec pi over 3, which is 1 over cos pi over 3. And cos pi over 3 is 1 by 2. Then let's get the tan. So this one is root 3. So that's that. Then we can also get the lower boundary sec 0, which is what? 1 over cos 0. And that will give us what? That will give us 1. So we now have ln sec pi over 3, which is 2, then plus tan pi over 3, that's root 3. You substitute your upper boundary, then minus sec 0, that's 1, then plus tan 0, that's 0. Actually, this will give us what? This will give us 0. So we just have this, we have this value. Then the next question is the b part, okay? And the first thing we do in the b part is to find the h over n, okay? And my n in this case is what? Is the 2 strips, okay? And that will be what? Pi over 3, which is my b, the upper boundary, minus a, the lower boundary, which is over 2. And this will give us what? Pi over 6. So the h is the interval, okay, the increments. Then we can form a table for x and y. Our values start from the lower boundary, start from 0, okay? Then the next value will be what? Plus this, plus the h, that's a pi over 6. Then this one also plus the plus pi over 6. You keep increasing your x by what? By the h, okay? So pi over 6 plus pi over 6, which is what? 2 pi over 6. And that's what? Pi over 3, okay? So you stop at the what? Your value must end at the upper boundary, which is what? Which is pi over 3, okay? So then the next thing to do now is to begin to substitute all these values into your function. Our y, the content inside the integral, our question, don't forget our question is sec x dx, upper and the lower boundary. So y is what? Sec x. So sec 0, that's 1. So that's 1 over cos 0, that's 1. Okay, do this one also. 1 over cos pi over 6. Yeah. For this one, that will give you 1.555. And then for this one, that's sec this. This is 1 over cos pi over 3. Which is, this one is 1 over 2, so this will give you 2. So we now have for b, which will be approximately equal to 1 over 2 times the h, which is pi over 6. Then the first value, that's the y substitute 0, that's 1, plus 2 times, actually here, this will be the first one is this, and this one is the last one. Okay, that will be what? 2 times what? 1.555. And then plus the last value plus 2. then you close it. So that will give us a 1.39 to choose significant figure. The C parts, we have 4 strips. So H is equal to pi over 3, that's B minus A, all over N is what? N is 4 in this case. So my H is what? Pi over what? Pi over 3 times 4, that's 12. So let's form the table. Let's form our table. Our x starts from 0, and then the increment is pi over H, that's pi over 12. Then this one, pi over 12. Then this one again, plus pi over 12. So that will be pi over 6. Keep, this one, pi over 12. Then plus pi over 12, which is equal to what? 2 pi over what? Over 12. And that's pi over what? 6. So then the next one, 2 pi over 12 plus what? Plus pi over 12, which is what? 3 pi over 12. And that will be what? That will be pi over 4. Then again, keep adding 3 pi over 12 plus pi over 12 plus your h, which is what? Which is 4 pi over 12. And that's what? Pi over 3. So you stop at the what? At the value of what? Of your upper boundary. So that's where your x value will end. And then you get the corresponding value for y. The y is equal to what? It's equal to sec x. So let's substitute the value. So for 0, we have what? That will give us 1. For pi over 12, so that's a 1.0335. That will be 1.55. Then for pi over 4, that's a 1.414. And then pi over 3 give us a 2. So this first one will be this. Okay, the second one, y1, y2, y3. The last one is a ya. So let's apply the formula. So I is equal to approximately 1 over 2 times h, which is a pi over 12. Then put your brackets. The first one, 1 plus 2 times 1.035 plus 1.55 plus 1.414. You close it, then plus 2. So this will give us 1.34 to 2 singular figure 1.34. So we'll finish the C parts. We're going to find percentage error. The new value we have in B, 1.39, minus the original value, which is this. Let's have the value for this one. Is equal to 1.316 or 1.316. Okay. So error in B will be the new value minus original value. That's 1.316 all over original value 1.316 times what? Times 100%. Okay, 5.6%. Okay, so let's get the error in C. This error in B. Percentage error in C will be equal to the value you have in C, which is we got 1.34 minus the original value, which is the one in A, 1.316 all over original value. If you multiply this, this will give us what? This will give us 1.5%. And this one, percentage error in C is more accurate because it's closer to the what? Original value, 1.056%. So C is more accurate. The value in C is more accurate.